Problem 28. So we're given this mystery set here with an operation star according to these four rules, and we want to show its group. So we know what a group is. This is our definition of a group. It's a set with an operation star according to these four rules. So let's compare the four rules we're given on the left-hand side with our mystery set with what we know the definition of a group is. And at first, everything seems promising. So number one, we need the group in operation to be closed, which we have, and we need the group in operation to be associative, which we have. Now, number three on the left, we're given what's called a left-sided identity, which means for any element x in our group, we have a special element multiplied on the left that gives us back the original element. We certainly need that. So in our definition, which says for any a, we have a left-handed identity here. But what we're missing is we need a right-handed identity. And it's a similar story for number four. Given any element x, we have what's called a left-sided inverse, which we certainly need. So for any a, we have this left-sided inverse condition, but we're going to need to show the right-handed inverse. And in fact, that's the clue that we're given in the book. So let's go ahead and try and figure out how to do this. So we'll start with E star or X star E equals X. We'll try and show that first. And we're pretty much all we have to work with is our red and blue equations up top. So I'm going to try and apply the blue equation to X star E, and I eventually want this to equal X. So the blue equation lets me replace E with Y star X. So I'm going to do that, and I get times Y star X. And the question now is, how can I proceed from here? I don't really have much to work with, and I already used the blue equation. The trick is seeing that if I could show that X star Y equaled E, well then what I would end up having is I would have E times X. And again, I want this all to equal X, but I know from the red equation that E times X just equals X, and I'm done. So in order to show this original equation here, what I need is I need X times Y to equal E. But notice that's actually what we need to show anyways to finish the problem. So in order for this to hold here, X times E equals X, we actually just need to show that X star Y equals E. That's sufficient to finish the problem. So let's try and show that X star Y equals E. Again, we really only have the red equation and the blue equation to work with here. If we try and use the red equation, we can replace X with E star X, and then we still have the Y over there. And then, let's see what else we can do. We can replace E with Y star X, so then we get Y star X, XY. But it's not really clear where to go from here. So let's try and use the blue equation instead. The blue equation, though, requires Y star X, or an E in there, but we already saw what happens plugging in for the E on the left-hand side. So to get a Y star X, one technique we can use that's relatively common is instead of looking at XY, we can look at XY times XY. So this would be the element squared. So if we called XY A, then XY would be A squared. And then instead of trying to show that XY equals E, we're really trying to show that A equals E. Those are the equivalent statements. And the reason why this is nice is because we end up with a Y times X in the middle there. And we know by the blue equation that we can turn this Y times X into E, and we end up getting XEY equals A squared. And by associativity, we can then go back to our red equation. So by the red equation, we have left-handed identities. So E times Y just becomes Y, and then that still all equals A squared. But what is X times Y? Well, X times Y equals A. So we get A equals A squared. So that's kind of interesting. We found an element that equals its square, but how can we use this here? And what we need to realize is that these are elements of the group by closure. We know X and Y are in the group, so their product is in the group. And A squared equals A, so A squared is in the group as well. And we have left-handed inverses. So the blue equation tells us for any element X, there exists a Y that we can multiply on the left. So let's let B be the left-hand inverse. So if A is in the group, we have that B times A equals E. That's the left-hand inverse. This is what the blue equation tells us. But b times a is just a squared. So that's equal to ba squared, right? And again, what we're trying to show is that a equals e. And we have that ba squared equals e, so if we can show that ba squared equals a, then we'd be done. So what is ba squared? That's b times a, and again, this all equals e. But then what is b times a? We have associativity again. B times a by the blue equation, again, we have our left-handed inverse, that equals a. Or sorry, that equals e. So then we have e times a, and then we have our red equation, that the left-handed identity. So that equals a. So indeed, a equals e, which means xy equals e, which is exactly what we needed to show to finish the problem. Thanks for watching this video. I hope you enjoyed it. Make sure to subscribe so you don't miss out on future videos. And if you have a question about this problem, or if you'd like to request a solution to a different problem you're working on, let me know in a comment below.